maximum power here to bring you your maximum power moment. Today's lesson is entitled The Discriminant. The Discriminant. What in the world could that mean? No doubt you'll say, I'm sure he'll tell us. But anytime we run into these names, we might want to look up their definition. The discriminant, an agent or characteristic that enables things, people, or classes to be distinguished from one another. An agent that enables things to be distinguished from one another, a characteristic. And so this discriminant is going to tell us something. Well, I will remind you that quadratic equations are equations of the form ax squared plus bx plus c, where a does not equal 0. And last time we derived the quadratic formula, which gives us the solutions to such equations. Minus b plus or minus the square root of minus b squared minus square root of b squared minus 4ac all over 2a. The discriminant, the thing that characterizes the solutions of these equations, is the guy right here. Right? This is called the discriminant because depending upon what the value is of b squared minus 4ac, we will have different solutions and we can characterize the solutions differently. So the first one here says that b squared minus 4ac is positive and it's a perfect square. So when we come in here and we plug everything in there, we might get something like minus 3 plus or minus the square root of 36 over 2, right? And that would be minus 3 plus or minus 6 over 2. Or I should say additionally, minus 3 minus 6 over 2, right? Two real solutions, and they're different. And they're rational. So I'm going to say when b squared minus 4ac is positive and a perfect square, we get two real rational roots. Right? They're rational numbers. They can be expressed as fractions. They are real. They belong on the real number line. And there's two of them. I could say here that there's two distinct real roots, really. They're distinct, they're different from each other, but I think one of our cases will make that clear to us. Okay? So, next on the line, anytime you want, you're invited to pause and think about this too and say, what could that mean? The next one says b squared minus 4ac is still positive, however, it's not a perfect square. So maybe something like we get 3 plus or minus the square root of 2 over 3. Something like that, right? That has two real roots, but how are they different? We have two real irrational roots. We have something, and they're distinct, right? There's two distinct, they're different. 3 minus square root of 2 over 3 and 3 plus square root of 2 over 3, different guys. What happens to the next one? B squared minus 4ac is equal to 0. Uh-oh. We end up with something like 2 plus or minus the square root of 0 over 0. Just 1. So we get 1 root. And is it rational, irrational? You can see that it will always be rational. Oh, no. I'm just going to say one real root, actually, because there's nothing that tells us that A or B can't be irrational numbers, right? So I wanted to stop and think about that for a second. other case here, b squared minus 4ac is less than 0. Good example would be something, we end up with something like 3 plus or minus the square root of minus 1 over 2. Uh-oh, what kind of answers do we have here? Complex, you're correct. How many of them are there? 1 or 2? 2, and they're distinct. So here we have 2 complex roots. And if they are complex, they have, and if they are definitely complex, they have an imaginary part. Okay? I want to move over a little bit now and talk about the graphs that we may have for these guys. We have 2 real rational roots or 2 real irrational roots. Here's an example of what one of these might look like. If it has 2 roots, it crosses the x-axis in 2 places. Okay? It could be up, it could be something, but the parabola is going to intersect the x-axis twice. If we have 1 real root, its graph is going to look something like this. As a matter of fact, this is the graph of y equal to x minus 2 squared. Right? If you were to FOIL it, you would have x squared minus 4x plus 4. And if you were to set it equal to 0, you could find its solutions by doing this. And you say, oh yeah, 1 real root. This is called a repeated root because it kind of shows up twice in the factoring, right? So we have 1 real root when the discriminant disappears, or when the b squared minus 4ac is 0. When this radical disappears, oh look, just one answer, huh? And it's real. 2 complex roots. This one I would like you to think about. What would the graph of this look like? Right? If we have 2 complex roots. Remember, we're trying to find the solutions to this. And guess what? There are no real ones. So there's no x's that are going to make this 0. So if we graph one of these guys that has a negative discriminant, we're going to end up with a parabola that does not cross the x-axis. Okay? I could make one up using my transformations, but I'm not going to do that. So let's look at 2 problems real quick. These say find the value of the discriminant and classify its roots. So we just do b squared minus 4ac and see what we get. 22 squared minus 4 times 1 times 121. You go to your calculator. I don't want to do that in my head this late at night. 22 squared minus 4 times 1 times 121. Huh. Check out that. 0. I guess that makes sense. 22 squared is the same as 11 times 2 squared, which is the same, let's do it. 2 times 11 squared, which is the same as 2 squared times 11 squared, which is the same as 4 times 121. Minus 4 times 121. Huh. Okay, so it's 0. So what kind of thing do we have here? 1 real root. And you guys knew that, right? Because look at, this can be factored as, look at 1 root, huh? So we have 1 real root. That's it. That's all we can say about it. 1 real root. Minus 5x squared plus 8x minus 1. Let's calculate b squared minus 4ac. B squared minus 4ac. 8 squared minus 4 times minus 5 times a minus 1. Ooh, a lot of minuses in there. 64. This is 20 minus 44. So where do we live in there? our discriminant is greater than 0, but it's not a perfect square, so we're going to have two irrational roots here. And that's that. So we are saying that we are calling the b squared minus 4ac part in the quadratic formula the discriminant, because by just looking at it and analyzing ABC without really doing much else, we can figure out what kind of solutions we're going to have and how many. A pretty good picture of what our graph may look like too. Okay, you're doing good work. Keep it up. I love you guys. Talk to you later.